How atoms pair up. Have you ever wondered how atoms recognize each other? Why hydrogen and oxygen so easily become water, why carbon bonds with almost everyone, and why helium behaves like it does not care at all? In Energy Filament Theory F, this is not about a mysterious chemical affinity. It is about something very visual. Atoms read each other through texture slopes in the energy sea. First, update the picture. The outer layer of an atom is not a cloud of little balls. It is a set of electron filament rings running on orbits around the nucleus. Each orbit has its own rhythm and swirl pattern. Together they carve a directional, rhythmic texture around the atom, like a tiny wind field. That outer texture is the atom's language. When two atoms come close, they do not first feel each other's mass. They feel whether their outer textures can lock in. The dynamic spiral patterns left by orbiting electrons create potential matching grooves, places where phases can line up. In some regions around an atom, the rhythm is easy to match. Energy that enters there can move with very little effort, like two dancers naturally finding the same beat. In other regions, the rhythm is always half a step off, so no matter how you try, the waves never rise together. Hydrogen and oxygen bond so readily because hydrogen's single electron path fits neatly into one open groove in oxygen's outer texture. Their spiral rhythms align. To the energy sea, the combined pattern costs less tension than to separate misaligned atoms. The sea allows that linked shape to persist, and we call it a chemical bond. Carbon goes even further. Its outer electrons can form four strong matching grooves, pointing in a tetrahedral pattern that is easy to tile in 3 dimensions. That is why carbon can build long chains, rings, and the complex frameworks life sits on. Helium is the opposite story. Its outer electrons form a perfectly closed loop. All the texture is wrapped back onto itself. There are almost no open grooves left for another atom to match. When you bring another atom near, helium does not push it away. It simply never offers a place where rhythms can sync. The energy sea keeps both atoms in their own low-effort states. We see that as inertness. So atoms do not grab each other with invisible hands. They listen for matching texture. When outer patterns line up, the slope in the energy sea tilts toward joining, and the atoms slide together. When patterns cannot lock, the slope tilts toward separation, and they drift apart. In this view, a chemical bond is just two atomic texture fields finding a shared least-effort path in the energy sea. Tap follow, share it on New Physics, Clear Universe.